So, welcome to this webinar, UNS in Practice. Good morning, everyone. I see a lot of people who already joined, so that's a good thing. Of course, whoever is not able to join, they will get a recording afterwards. My name is Bart Mans, and I'm pleased to give you this webinar, UNS in Practice. Today's content, we're first gonna introduce AT automation. I'll keep it short, of course, because all of you are really interested in the Unified Namespace, UNS. Then I do a quick introduction in the UNS as well. Then we take a look at architectures that are practical. Of course, due to confidentiality, I'm not able to share customers' projects right here. So I made a little cookie factory UNS, and I use the architectures and especially the data and the topic structures for that. And eventually I will share with you the AT automation project approach of implementing a UNS in practice, of course, and how we do that. And eventually I'll close up and we have a Q&A. All of you can use the chat of this webinar on Webinar Geek. And in the chat, you can just fill in the questions that you have. And at the end of the webinar, I'll try to answer most of them. All that I'm not able to answer straight away, of course, we always will answer them. So via email or chat or Teams call or whatever. So please feel free to ask questions. Already now, you are able to ask questions straight away. So I might be able to answer them during the webinar. So again, thanks for joining, and let's get started. So first, who am I? My name is Bart Mans. I'm Innovation Manager at AT Automation for 10 years now. So 10 years ago, I started here as an intern. By the time I wanted to learn something for the industrial field. So I thought I wanted to become a PLC engineer. So that's what my study told me. So I always was interested in PLC programming and building control cabinets and such. Then I started at AT Automation. We had a request for a SCADA and MES solution. So we did a search, found Ignition, and I never let Ignition go. So for the past 10 years, I'm working with Ignition. And as an innovation manager, I'm responsible for the new technologies that we introduce within AT Automation, specifically on the SCADA and MES field. I take a look at the new innovations related to Ignition. And of course, very soon, later this year, we will have Ignition 8.3, which is a major new release that we'll be looking into. I'm sure there will follow some content regarding that, but that's part of my job. And of course, I'm responsible for the trainings that we provide internally to our colleagues, but also to our customers and students as well, of course. Let's have a quick look at AT automation. And whenever I try to explain what AT automation does, I generally take a look at the automation pyramid. The automation pyramid defines all the different levels in the automation field. And the lowest levels, the sensors, PLC, HMI, we do with the controls engineering department. So with the controls engineering department, we make sure that all the sensors are cabled, that the sensors are installed in the field on the machines. We make sure that we have the control cabinets set up. We make the E-plan drawings for that. We program the PLCs, we program the HMIs and such. And then we reach the supervisory and planning level, HMI, SCADA, MES. We do all of that with Ignition. So we use Ignition as one platform for all those layers. And of course, we also use Ignition on the industrial Internet of Things layer, which is on the left side, a real layer actually. But so we are collecting data from sensors directly and pushing them upwards on the pyramid. We can push data into a SCADA or MES or even an ERP system. So this pyramid actually perfectly describes what AT automation is doing. We do it in the fields, in the production industry. So our customers are producing goods, producing food, producing materials, concrete, metal. It's really diverse. And we do everything on this pyramid except the ERP. But of course, we have a close collaboration and integration with ERP systems. So we touch them a lot. And in that case, it doesn't really matter which brand or type of ERP system you have. As I mentioned, the SCADA and HMI, SCADA and MES layer and IoT layer, we do with Ignition. And we use Ignition since it's really diverse. It's capable of doing all those layers in one system, and it's also capable of communicating with all the PLCs and all the ERP systems, which makes it our, of course, favorite system that we use. This webinar, of course, is looking at UNS in practice, and the UNS, you can build it in any other system, but the examples that I showed today are all built in Ignition, of course. Well, let's start with the UNS itself. So why are people interested in setting up a UNS? As we can see on the left side and the left image, most companies have a distributed architecture. There are many different systems that are all integrated with one another. We have, how we call them, point-to-point integrations. So a database talks to an OE application, a SCADA talks to an ERP system, a MES talks to an ERP system, and all of them interact one-to-one, so point-to-point integrations. It's really hard to scale, as you can imagine, because let's say we need to replace the SCADA system. In this architecture that we see here, it has 3 connections, which means that we really need to redefine those 3 connections. So it's better to set up a centralized, unified namespace that we call the UNS. So on the right side, you see the UNS architecture. It's the solution, of course, for this challenge that I just described. The UNS enables a single source of truth for seamless and scalable data exchange. And of course, this is a composable architecture, because if we want to compose, let's say, the SCADA, we just have to redefine one connection. We may need to make sure that the data from the SCADA to the UNS remains the same. So if you replace the SCADA, we just make sure that all the data points are exactly the same as they were previously. All the other systems won't even notice that there is a different system. So it's really a composable architecture. One of the key benefits of the UNS is that it is a single source of truth. All data is integrated in the UNS on a single location. It is a real-time platform for real-time data exchange. Of course, this enables scalability, standardization, and that way you can, of course, make business impact. When we take a look at the general architecture for a UNS, a unified namespace, we take a look at this image. We have the unified namespace in the middle, and it connects to any other system, like an ERP, MES, but also edge systems or machine learning systems and such. So the unified namespace is always in the middle. Of course, this is a really schematic overview of such an architecture. So let's take a look at a more technology architecture. So how the UNS generally works is that we have a message broker in the middle. This message broker gets messages from producers that are clients that produce data, and consumers are asking the message broker for updates. So the consumers are actually asking the message broker of values. I forgot that I have to not show myself, so you have a better view on the slides. So I will quickly turn off my camera. So let's have another look at this general architecture, how we can really deep dive into this. So we can do that there. So whenever we take a look at the general architecture from a multi-site purpose, then of course every site, as we can see in here, has a SCADA and MES solution. This SCADA and MES is connected to PLCs, as we can see on the bottom. The SCADA and the PLCs, they communicate with each other, and the SCADA or MES system knows exactly the states of the PLCs. Of course, we have some enterprise systems, like for instance, an ERP system. So one of these enterprise services on this image can be the ERP system. Another enterprise service can, for instance, be a machine learning interface. And all of them are interested in the data that is produced, but also consumed by the SCADA or MES system. That's why we have the 2 arrows. So the blue arrow is data moving upwards from the SCADA MES system into a message broker. And the orange arrow is data being consumed by the SCADA or MES system. In this setup that we see here, we have 2 sites that are both sending data to the broker and using data from the broker. And then on the enterprise level, we have, in this case, 3 enterprise services that do something with the data. They consume the data, but they will also probably produce some summaries, for instance, of the data. Whenever taking a look at how the broker and a client works, I use this slide here. So we have 2 clients, site A and site B, and we have 1 broker. So let's say site A is sending data to the broker. So this is publishing data to the broker. And whenever some data is being published to the broker, we define a topic, which is actually the name of the data point. In this case, it's AT, site A, and a tank level. And the tank level that we're interested here has, in this case, a value. So in this case, a payload of 13. So it's being sent to the broker. So the broker makes a structure out of the data. Then we have site B, which is also sending some data. And they also have a tank level at site B. And the payload, the value is 65. Both of them will come in the broker. And the broker now has a unified single source of truth of the data. Whenever we have these two clients are publishing, whenever we have a client that's subscribing to the data, it will receive all the data points. In this case, whenever site B, for instance, has a different topic, let's say a tank temperature, we can also publish that temperature to the broker. And the broker instantly adds the value to its setup. Whenever the client on the top right subscribes again to the values, it will immediately also get tank temperature. In this case, I'm not really describing a technology, but I'm describing a structure, how data is being sent and handled. And generally, we use MQTT for this communication, which is really optimized for this set of communication. If the client on the top right does some calculations, so let's say it's calculating a total level, total tank level, it can calculate that level. However, since that client only subscribes, the broker doesn't know that total tank level. If that client on the top right will also publish the data, then the value will also enter the broker. And in this case, clients on site A or site B can also use that data if they would also subscribe to the data. In this case, on this image, I haven't made the subscription option, but then both of them will also have the total tank level. And they can do some logic with it, of course. So that was a general understanding of what a UNS is. Of course, whenever you want to know more about how the UNS is and how it's being set up, please have a look at any of our other webinars, because we made more of them, of course. Whenever we take a look at the communication itself, I just mentioned we can use MQTT for that. It's a common language for communicating. And the MQTT communication, it's consisting out of different levels, level 0 to level 5. And the MQTT is defined how those levels are used. Of course, on the transport level, it uses TCP in a WebSocket, and then it's using the protocol MQTT. On top of that, we call it flat MQTT, we can define our own mapping, our own encoding, our own value structures, and our own objects. Well, we can define all of that, which is a major task of someone who needs to incorporate MQTT communication, defining how communication will take place. What we often use, especially in the OT, operational technology layer, is that we use SparkPlug in that case. SparkPlug, it's helping us as engineers to define that communication. So it's defining the mapping, which uses the SparkPlug protocol. The encoding is going through protobuf. And SparkPlug defined 19 different base data types, like a Boolean, string, integer, and so on. And it's also supporting custom types. We can then we can then make the custom objects. So let's say I have a tank, which has a level, a temperature, and a pressure, for instance, which uses any of the 19 base data types. So the SparkPlug communication helps us to define the type and the way of communicating. We have to take a look at the use case itself to define if we should use flat MQTT or SparkPlug or any other type of communication. Because whenever we take a look at Ignition, we could also use the Ignition Gateway Network, which is an internal network of Ignition gateways communicating to one another. You really need to define what's the use case of the UNS and which communication type do I need to use. If we take a look at MQTT using with Ignition, we can come up with an architecture like we see on this picture. In this case, we have different servers. So we have one normal PLC here. We have two normal PLCs connected to an Ignition Edge, which is a small, lightweight version of Ignition. which publish the data. In this case, the edge publishes the data to a central MQTT server. In here, we have a full ignition server that is connected to, for instance, an entire factory. That full ignition server can also publish the data to the MQTT server. And maybe on a central location, somewhere in the enterprise domain, we do have another ignition server that can publish and subscribe to the data. It can subscribe to the data to get the data of any of these other publishers here. And then it can make some calculations like we just did with total tank level. And it can publish that data back to the MQTT server. And then, of course, we have solutions like AI solutions, ERP solutions, but yeah, you can define, of course, which solutions will communicate to the MQTT server in the middle. And all of them can subscribe or publish and subscribe. If we take a look at the same architecture, but then from an ignition module perspective, as probably most of you know, is that ignition is a modular platform and it consists of different modules. Each module you add to the platform will add functionality to the entire setup. And in order to communicate over MQTT, we need some MQTT modules. And in this slide, I'll try to explain the different modules that we can use. So in this case, the Ignition Edge is generally able to publish data to a central server. Whenever we use an entire Ignition server that should be able to publish data, we need the MQTT transmission module. The transmission module makes it able to send data to a central server. So the Ignition Edge has a small transmission server included in itself. Whenever we take a look at this enterprise Ignition server over here, it's able to publish and subscribe. And for that, we need the MQTT engine module for subscribing. And for publishing, we could use the MQTT transmission module. However, the engine is also able to publish some data as well. I'll explain it in the next slide. And on the central location, we could, for instance, use the Chariot MQTT server. The Chariot MQTT server is a standalone MQTT server that really connects good with Ignition. We could also use the MQTT distributor module. So the module means that this distributor is a part of the central Ignition server. So in this case, we have 3 servers. One is the central Ignition server over here. We have an Ignition Edge, which is an Ignition server, and we have, in this case, a side server here. If we take a look at Ignition, we have the MQTT distributor module, or the Chariot, which acts as an MQTT broker. It receives all the messages and it is able to share those messages and those values with other clients. We have the MQTT transmission module, which publish MQTT data, and it can publish them at SparkPlugB or flat MQTT. The MQTT transmission module also accepts a write-back over SparkPlugB. However, in that case, the MQTT publisher or transmission module needs to be the owner of the data. So as an example, and I go back to the previous slide, an Ignition Edge system, it can, for instance, have a tag, a value called set point temperature for a tank. And that set point temperature, it's made, the value itself and the tag, it's made in this Ignition Edge. It can publish that data to the broker and to another Ignition server. The other Ignition server is able to write back on that tag if write back is enabled. However, the tag needs to be made by the Ignition Edge. The MQTT engine is actually an MQTT subscriber. So it is subscribing to the broker and it's subscribing to the data. And this can support write back over SparkPlugB, but then it needs to write back on tags that are made by the MQTT transmission module. I hope all of it makes sense. If it's a little bit too difficult, please watch any of our previous webinars on the UNS where I explain this in more detail. Or, of course, contact sales or any of our engineers. If we again take a look at the general architecture that we made and that I showed previously, we see that we have a broker here on the enterprise level. The broker is located not on site 1 and not on site 2, but it's on the enterprise level. So this broker has enterprise data. In this case, it makes sense that this broker communicates with both of the sides and with all the enterprise services. If this broker, so if I take a look at the broker itself, I would propose here to have a MQTT broker that uses flat MQTT. Since in general, enterprise services generally do not support SparkPlugB yet. So this is actually an IT layer and the IT field. So we use more flat MQTT than the SparkPlugB protocol. Whenever I take a look at a more in-depth structure, take a look at this multi-broker architecture. It's like a hub and spoke architecture, where I have a MQTT broker on the enterprise field, the same that I just showed. But on the sites themselves, I do not have a PLC connection directly to the SCADA and MES system, but I have an MQTT broker in between. This broker is locally getting all the data from the PLCs to an Ignition edge and is able to communicate back and forward over this setup down here. In this case, we use a combination of flat MQTT and SparkPlug protocol. The green arrows, as you can see, is the SparkPlug data. It's on the OT layer. And the blue and the orange arrows are just normal flat MQTT. So in this case, we're using a combination of either of the two. SparkPlugB, as I mentioned earlier, has a lot defined. It has a lot defined in structure, in values, in data types, and so on. And it also has some options to ensure that the data is going back and forward. So it's called the quality of service. If you want to know more about that, please ask us and we'll explain. So in this case, whenever I take a look at the two sides and the enterprise, we can see that we have three brokers here. So we have this enterprise MQTT broker, we have site 1 MQTT broker, and site 2 MQTT broker. In this case, I use MQTT on all three levels, but MQTT is just a technology. It's not the structure itself. Whenever we want to set up a UNS, we could, for instance, also just connect the Ignition Edge devices with the SCADA and MES system without the use of an MQTT broker in between. As I mentioned earlier, we then use, for instance, the Ignition Gateway network. A benefit of the MQTT broker is that it's composable. It ensures a composable setup. So if I would like to replace this edge device, which can now be Ignition Edge, with a PLC that can communicate MQTT straight away, then it's easy to add in this network. Because it's composable, we just have to make sure that the data going upwards and going back is the same in the new structure. What's important to mention in this image is that the SCADA MES layer is now used as a translator. So it's translating the data from this MQTT broker into the enterprise MQTT broker. But it's important to mention that a translator does definitely not have to be a SCADA or a MES. It can also be another solution that is able to take data from, in this case, an OT MQTT broker and send it to an IT MQTT broker. So whenever we take a look at the previous slide, this is a full SparkPlug on the OT level. So we have SparkPlug here, SparkPlug MQTT broker on the site, and all communication in the OT field on site is SparkPlug. So we have the Ignition Edge, which sends up the data to the SparkPlug MQTT broker, which sends the data to the Ignition platform, which can be a SCADA or MES. And there, the engine will subscribe to the MQTT data here, and the transmission module will send the data upwards to the IT MQTT broker. The IT MQTT broker makes some changes to the data or provide some values back. The engine will collect the data and will write back to this MQTT broker here, so the Ignition edges can use the data. We can also have a setup where we use a hybrid approach. So we use the MQTT transmission module to send data to the local OT MQTT broker, but we use the MQTT engine to gather data from the IT broker straight away. So in this case, for instance, an IT system, like an ERP system, can put the open orders that need to be produced in the IT broker. And the Ignition Edge can gather those orders straight away from the IT broker. So there's no need for the Ignition platform, the SCADA or MES here, to define which order needs to go to which Ignition Edge. All of that can be done directly from here. However, of course, we would need an MQTT engine in every ignition edge, which is, of course, is also a business impact. So this is a hybrid local setup where we use Spark B communication to a IoT broker, and we use flat MQTT to a IT broker. We can also have a hybrid enterprise setup where some of the ignition edges communicate over OT, net to the OT MQTT broker over Spark B, and some will communicate directly with the IT structure, so with the IT MQTT broker. In that case, we also need an MQTT transmission module and an MQTT engine to gather the data. It is important to mention that with MQTT, it's really important to define who is able to change values. So in generally, this MQTT broker, it collects all the data that gets published to them. So if a value gets published, all the equipment that subscribes to the data will get that new update of the value. In this case, we don't want, for instance, a random IT system to change values in a PLC, for instance. So that's why we see an OPC input and output down here. So the engine is writing the values to an input field, and the PLC will first make the choice if it does something with that. So let's say we have a tank which can fill 100 liters. Of course, you don't want a random IT system to write a value to the PLC. Hey, please fill the tank with 150 liters. That, of course, is not what you want. That's why we definitely always want some OPC PLC logic that validates the data and that if it's correct. So we just had a look at the different architectures. Of course, there are many different architectures possible. This is just a setup of some basic architectures that we have seen in different use cases. So they are real use cases from real customers. We will now have a look at the different data structures, the topic structures, how I call them. And generally, most customers from us use the ISA 95 Part 2 structure, where we have an enterprise, site, area, production line, and work cell eventually. However, this setup helps to define the structure within a company. What we saw, and the guys who know Walker Reynolds, of course, he introduced the different types of namespaces. For instance, descriptive namespace, informative namespace, functional namespace, and ad hoc namespace. Because in a work cell, you could have data that is related to the installation date of the work cell, or that is related to the supplier of the work cell. For instance, who is the machine manufacturer, when it's installed, when did we do the last maintenance on this. Other data that's in the work cell is what's the current speed, what's the current OEE. So there's a lot of data in the work cell, which we really would like to divide in how we call them namespaces. I'll give some examples from our cookie factory in a bit. So if we take a look at, let's say, a cookie factory, we have a factory called Cookies & Co. It's the enterprise. It has a site here located in Weert, and it has different areas. One of the areas that we are interested in this case is the packaging area. And the packaging area consists out of a process cell, which is a boxing line. The boxing line is responsible of boxing, of course, the cookies in carton. The boxing line also has a unit in there, which is a conveyor. It's one of the conveyors of the boxing line. And this conveyor has data, of course. It has an equipment ID, which can be the same ID as used in the ERP system. It can have a status, for instance, running, stopped, faulted, and so on. The boxing line itself has an energy consumption. The conveyor itself has an energy consumption. But we can also take a look at the boxing line as a whole. The boxing line, just like the conveyor, can have a status. Well, the conveyor itself won't really have open orders that need to be produced. However, the boxing line will have those open orders. The boxing line will also have, for instance, the current OEE or the previous OEE. So this is data that we are interested in. And this is data that we potentially want in the UNS. If we take a look at the data, we can divide it in different namespaces. And we could use the names that I just explained. So we could, for instance, say The equipment ID, which has a value, of course, we put it in the descriptive namespace. So you could see this structure as a folder setup. So we have a folder called Cookies and Co. We then have in Cookies and Co. we have a folder called Weird. We have a folder called Packaging, Boxing Line 1, Conveyor 801, Descriptive. Then in the descriptive folder, we have a tag called Equipment ID. And the tag has a value. Well, we will have a functional namespace that, for instance, tells us about the status of the conveyor. And we have an informative namespace that tells us something about the energy consumption of the conveyor itself. Then, of course, the boxing line has some functional data like the status, which is not exactly the same as the conveyor because the conveyor can be stopped because a jam. However, the boxing line might still be running since there are still some boxes in there. The boxing line can have a set of open orders, which can be a data set, or in this case, a JSON. So it's data of order 1, order 2, what the product ID is, and how many we need to produce. And of course, we have a functional namespace like OEE. It tells us something about the current OEE, 58%, and how that's being composed out of availability, performance, and quality, of course. Again, this is just an example, but this this looks as an example in this slide, but this is an actual customer setup that we have seen in the past years and that we have been working on together with our customers, where we use the different types of namespaces and we described and we give them the name like previously shown: descriptive, functional, informative, and ad hoc. Ad hoc is often being used as a folder where we can put in raw data. So let's say that's the data coming from the PLC directly. So the boxing line 1 here has a functional status of 3, but in general, that could be 4 booleans coming from the PLC that says in running, in production, stopped, error. And all of that we recalculate into a functional tag called status. So that's how these different namespaces are being set up. Well, so this is an example where we use the namespaces as a division. We could also divide the tags in categories. And there, for instance, we have a category called asset information. And in asset information, we can have a tag called equipment ID, which has a value. We can also have a tag which tells us something about the installation date or the manufacturer. Then we have a category called status. And in there, we have a tag also called status. But in there, we could also have some booleans that tell us something about the status or some communication with an end light. And we have a category called process values. In there, we, for instance, have the values coming from the machine, like energy consumption, temperature, speed, and so on. However, all those values are normalized as much as possible. So we can really compare the speed, for instance, for conveyor 801 with 802. You want to make sure that you are able to use the data. And then when we take a look at the boxing line itself, so not on the unit level, but on the process level, we have a same set of categories where we have tags in. So we have a status category that tells us something about the status itself and a status tag. But the OEE is also a status of the boxing line. The current OEE is a status. And we have a set order data with open orders that host the same orders as we just saw. But we can also have a tag called closed orders, which also has a JSON or a data set with all the closed orders. Another customer of ours has used the automation levels to define categories. So we, of course, then have also asset information, but status tag, for instance, it can be MES data. The energy consumption can be data coming straight away from the PLC. So you could use then the automation levels as a division there. The ERP system is responsible for the open orders. So we make a folder called ERP that hosts all the open orders. And in that case, the customer also has set up a folder called dashboard. And the dashboard they use to really make dashboards. In the dashboard folders, we have the data that we use in order to show an OEE overview. Actually, all other systems that access this data can straight away look into the OEE, the dashboard folder, and make it the same dashboards for all the OEE applications. All systems are looking at the same single source of truth. That's the entire idea. Another setup that we can use here is a division in compositions. So let's say I have a cookie factory in Weert, which is a packaging area. And then we have equipment called the boxing line one. And this boxing line one consists of different assets. So we have a folder called assets, and a tag consists of. And there we have some IDs of assets that are in this boxing line. In this case, we can assume that this boxing line changes assets oftenly. Let's say they add a conveyor or remove a conveyor of this boxing line. In this case, we can keep the same UNS even if they change assets. The only difference here is that the value in consist of tag has a different value. So we can remove an ID or add an ID here. Of course, this box line still has a status, it still has order data, and so on. Then we also have a folder in here called assets. And the assets folder consists out of all assets, a conveyor 801, 802, and so on. And they, of course, have an equipment ID and a status. If you really want to combine the data from the boxing line 1 and the conveyors, we just need to have a look in the assets folder, consist of tag, and then we need to take a look at the IDs that are used within boxing line 1. And then we are able to see the statuses of those tags. So in this case, it's a little more difficult to walk through the UNS, like opening folders and finding tags and such. That's a little more difficult. However, all data is there. So you just need a system that helps you to identify the data and make the bindings there. The big positive side of the division and compositions here is that whenever we move an asset, the historical logging, for instance, for the status of conveyor 801 will always remain in the same tag path. So we're always able to take a look back in time, let's say a year, and find what was the power consumption or what was the status of the conveyor back then, even if it is moved from one machine into the next. So that's a real big benefit of the division and compositions here. If you're not changing compositions often, then it doesn't really make sense. We've also seen customers where we have helped them and where we defined our own payloads. And that's something that we do more often when we use flat MQTT. We are able to define the payloads our own because flat MQTT doesn't define the payload. It just defines the protocol, which is MQTT. And then you can, for instance, make a folder called units conveyor 801 with a folder called a tag, called asset information. And in asset information, we host an entire JSON with all the data related to the asset. Instead of making multiple tags, we combine everything in one tag. For instance, on status, we show the status, but we also add the status type, which is PACML, for instance. Or on process values, we have the energy consumption and the speed combined into one topic. In this case, you of course get less topics or tags within Ignition, and you combine all the data. Of course, the data is packed in a JSON, which you need to unpack again. So you need more logic on the producer and on the consumer side in order to do something with this data. However, you remain more flexible. So if I take a look at, for instance, at this order data, and now I have the open orders and the completed orders. I can also, for instance, have the scheduled or orders that I think will come in the coming week. So I can set up more data in this same structure. So I can keep the tag order data, but I can enlarge or make the payload yet smaller. I'm more flexible to that. Another thing that we have seen the past years and we have worked on with our customers is using multiple dimensions, or actually paths. Because the thing that you saw in the previous slides is that the data, the values remain the same. However, the location of the values, that changes. So actually, the folder structure in the tag structure from Ignition will change. So the tags and the values will always remain the same. So what we could do, we could, for instance, make a tag called alternative paths in a meta folder or in a meta set of the tag. And in there, we could, for instance, have the normal location, the ISO 95 locations, like Cookies & Co., Weird, Packaging, Boxing Line 1, Conveyor 801, Asset Info. But we could also have in English, a really location, a physical location like hall 12, and then location A7. In this case, I imagine a map of the factory with where you can just find where conveyor 801 is located within A7 in hall 12. But if we have a company that has multi-language, that has multiple locations, we could also set up a German ISO 95 structure. And then we use the same terms as up here. However, those are translated. In this case, I can bring this asset information. I can bring back this asset information from the standard structure, but I can also set up my entire UNS from the German structure since the data isn't there. Of course, I need some logic to restructure the data and show it again to the end user. So that's something we can set up there. And for instance, we can also look at the German side from just an asset perspective, where we have all our Geräte combined. And there we have our conveyor with the asset information. So we can really use those multiple dimensions. Actually, paths in ignition. So that was UNS in practice, some practical examples of structure and architectures. I here also have a practical example of the project approach, the UNS project approach that we use at AT Automation. And in that case, I first want to look at the industrial IoT maturity model. This model actually describes the steps that we need in order to get to Industry 4.0. First, of course, we need computerization. We need logic. We need PLCs. We need servers that are able to get our data. Well, whenever we have that, we need connectivity. And with connectivity, we are combining assets and we are collecting data. The UNS is a really good example of how we can make that connectivity. Then we go one step further. We can make sure that we are able to see the data. So for instance, I make a UNS and I visualize it with ignition perspective. I can make screens where I can see the data. Or I'm using historian in order to historize the data. We can also do that with ignition, of course. And then whenever the data is visible, someone is able to see the data, we can go to the next step, which is transparency. Someone can really go through the data and find patterns and do things like that. So we can understand the data from itself. Whenever we have the data, it is visible, it is computerized, it's connected, it's visible, it's transparent. We can go one step further and we can use the predictive capacity. So we can use models to predict what will happen next. So we're getting prepared of what will happen. In that case, you use statistical process control or any AI solution that is able to prepare and predict what will happen in the future. And based on that, we can take action. And whenever you have gone through all those steps, you can go to adaptability, where you can have a self-optimizing system. The system is able to gather data and it's able to make choices based on the data and bring those choices back to the equipment itself. So these are the steps. And as you can see on the left side, I've added an arrow with value there. The value is getting higher the further we are in this process. So it's really important to not expect direct value of just setting up a UNS, because that's just the second step of this structure here. You will need to make sure the data is visible. You are historizing the data. You are visualizing the data with perspective and such. And then you can go to the next steps. So it's really a stepped approach. If we take a look at the UNS approach, how AT Automation sets up a UNS, most customers of ours start with the standardization topic. They say, we want to connect, transform the data, collect it, store it, analyze it, find patterns and things like that, make reports and such. That's a great approach. And we should standardize, of course, whenever setting up a UNS. But in order for us to be able to standardize, we first need to transform. And in order to do that, we will always start with an orientation phase. We will do a test, a pilot, which we need to make sure it's small. Then we can scale that test and we find patterns or we find disadvantages of the pilot that we did. And from there onwards, we can standardize. So we always want to start with transformation before we go into standardization. Really important. So when we take a look at the first standardization phase or orientate, what we do is we want to understand the data landscape. We want to see what systems are there, what are existing systems, and how can we design an architecture on top of this landscape. So we will do a system analysis. We will do some workshops looking at the architecture, looking at a business case, design a basic UNS structure that we could use, and the outcome is a UNS design for a pilot. And of course, we use a holistic approach here so we can reuse this pilot data, pilot setup for the entire factory, of course. When we then go to the next step, the test pilot step, the objective is to test and develop an initial version of the UNS. The activities that we do is that we create a pilot, which is designed already in the orientate phase. We test the pilot in a controlled setting. It's really important that we have a correct setting where we can test the pilot. We will review it. We will adapt it, of course. So we have some iterations here, depending on the fit. We can have one or multiple iterations. And then we have a redefined understanding of how we can use this UNS in practice. And based on that, we can further scale the test. All of that, of course, is dependent on how the pilot went and what is the objective. And when we scale the test, we can standardize, and then we go into standardization. We can define a standard which we can roll out across the entire factory or enterprise. Well, so I went through the architectures, data topics, but also project approaches, and I gave you guys a general understanding of what UNS is and what we can do with it. Some lessons learned or some summary that I would like to go through is in order to define the UNS, you really need to choose the architecture, the message type, and the topic structure, which we just went through. And we as AT Automation, with our project approach, can help with that, of course. Whenever we want to start with the UNS implementation, it's really important to first orientate, test, do a pilot, and then we scale. So these are really important steps of the UNS implementation. Which is important and pitfalls is that we have customers which expect a direct value. Of course, we need to go through these implementation steps. A direct value can exist. However, we need to first focus on that pilot and bring it as a successful pilot. So do not expect direct added value. We're not able to implement AI straight away. We first need to make sure that we have data that is good data. So the data can be full of bad data points, or maybe there are some connectivity issues. Then AI will not have its value or cannot deliver the value. So do not expect a direct value. And on any of the other pitfalls is over-engineering. It's really important to just get started. Orientate and do a pilot. And based on the pilot, we will learn how to continue with a further UNS implementation. We can think of the UNS setup for years. However, you want some steps to be taken, of course. And one other pitfall is the OT-IT difference. So whenever we are setting up a UNS, and you saw it in the architectures earlier, is that we have OT architectures and IT architectures. In the OT architectures, we're really looking at, for instance, Spark Plug B, communication with PLCs, factory networks, OT networks. Whenever we take a look at IT, of course, IT comes involved. We need servers, we need firewalls, and all of that. So it's really important to bring the people of both fields together. In some companies that we help, some customers of ours, those are the same people, which is really cool because we can talk on the OT side and on the IT side with the same people. But there are also customers of ours where it's really divided and they don't even talk with each other. But it's really important because setting up a UNS will involve OT and IT. So we need to bring those people together. So as AT Automation, we are helping our customers to guide the standardization and eventually the transformation and then the standardization. How we will do that, whenever we take a look at a distributed architecture, where we started this presentation with, we first have a look at one of the point-to-point connections. For instance, the communication between an MES system and the ERP. We then set up a UNS architecture. This could be the pilot, where the MES system communicates with the UNS and the ERP system communicates with the UNS. Whenever that pilot was successful, we can scale and we can go to the entire architecture. We then go away from the point-to-point connections into a UNS, single source of truth, and composable architecture. That was what I wanted to tell you today. I hope I gave good insights in how we have implemented the UNS in practice. As I mentioned, I wasn't able to really show the real customer examples of confidentially, of course. However, there is a use case of a UNS with one of our customers coming up in a few weeks. We have set up a case study, and yeah, we are able to share that. But we still need some processing for that. If there are any questions, please feel free to ask in the chat, and I will go through. I see something has already come in. Have a look here. Someone says, I have a question, but I don't see the question. Oh. Right. I have another question in here. What exactly is a unified namespace and how is it different from the traditional data model? For that, it's for me quite simple. I just go back one slide. The UNS really is that centralized single source of truth. It's really important. The traditional data model is more communication from one system into the next. If we then take a look at one of the point-to-point connections, the MES system only has, for instance, the open orders, which communicates to the ERP over the, and it's going to talk about those open orders, if they are finished or if they are due or whatever. And the other way around. So if the ERP system talks to the MES system, it's only interested in what did the MES system really produce? What data is produced? It will never talk about a specific temperature somewhere in the field. Well, with the UNS architecture, the ERP system also has the accessibility of the data directly coming from a PLC or from a SCADA system. So if that data is interested, the ERP system can easily access that without the need of adding another point-to-point connection. But that's the difference from a traditional data model. Another question here. Is only the connection with the PLC possible, or is it also possible to connect to HMI or different BNR system? That's a good question. So with BNR, you're talking about BNR PLCs. In general, the data needs to come out of that equipment. We use ignition in most cases, and we use then also ignition edge in that case. So I'll go back a lot of slides actually in order to show that. The architecture. This one. So in here, you can see where the data is coming from. In this case, I do have, for this PLC, in order to communicate with this MQTT server in this case, I would need a PLC that can communicate MQTT. It can be SparkPB or just a flat MQTT. There are nowadays PLCs that support MQTT straight away. If you do have a PLC or HMI or any system that is not able to communicate MQTT directly, we can, for instance, put some middleware in there. And the Ignition Edge can be the perfect middleware for that. Ignition is known for its many drivers. And so we have Modbus, Profinet, Allen Bradley driver, Omron driver, Mitsubishi driver, and so on. I would need to know which BNR system you're talking to and what drivers those support. To see how we can make that connection. But Ignition, it is known for its many drivers. So I expect that we can somehow get the data out of there, maybe directly to the MQTT server. But if that's not possible, we always use the Ignition Edge in between. So yes, we're always able to get the data out of the PLC and send it to an MQTT server or a broker centrally. Doesn't have to be MQTT. And we can use Ignition Edge for that. Yeah, I hope that answered your question. Right. Someone had a question about the third dia. I see that I forgot numbering. So 1, 2, 3. Layers of MQTT. This one. Come back. This one. 2 layers of MQTT connected. The MQTT broker, PLC. Yeah. So the question is, can we connect the PLC directly to the MQTT broker? Yes, that's possible. If and the same applies to the question that I just answered. If the PLC is able to communicate over MQTT, it's definitely possible. I use the SCADA MES here as a translator, but if the PLC is able to communicate with a broker, you don't need the SCADA MES system in between. However, the question is, what data is being sent to the PLC? If it's just an upward connection, it's definitely possible. If it's also a downwards connection, so let's say you have an enterprise service that is filling in set points for a tank temperature, you have to define where the data is coming from and how the PLC should react on that. Of course, you want to prevent that some enterprise service is sending data to the PLC which is not structured or which is not secured. So you need to make sure that all of that is being set up. But that's something we can do and what we often do with a SCADA MES in between. But that's also something you can, of course, make sure that in the PLC that takes care of that. Did that answer it? Yeah. You're welcome. I have a question here. When I want to start up setting a UNS, where do I start? Well, of course, reach out to us, and we will help you with that. I hope that the project approach that I went through in this webinar can guide you in that. We do then host workshops with different people, and we can set up workshops. I will quickly go there. We can set up workshops, for instance, on an educational purpose, where we can help all the people who will be involved in the setup of the UNS. We can help them to educate them and explain to them what we will do and what it means to set up a UNS and what you need to think of. We will have workshops that go through the architectures because, as you saw in this webinar, there are many architectures possible. So we have a look at that. And we will have, of course, a look at the business case, because if you do not know the business case, it's really hard to define the architecture and the topic and the payload. We need to have some sort of business case, what you want to achieve with the UNS before we can start with setting one up. Another question, which departments in my organization can profit from a UNS? Well, actually everyone. We have customers where even the operators are able to browse through the UNS and they can see data that they normally couldn't see. Or we have maintenance engineers that take a look at the UNS. So they take a look at the UNS, for instance, they have a failure, a motor failure, and they can use the UNS because the UNS had data from the ERP system, from the PLC, from the SCADA, from the MES, and all of that. It has all the data, and they can go back in time, let's say half a year, and they can look at a snapshot of the entire factory from half a year ago. And based on that, they can find patterns, or they can understand why the machine broke down. One other question was regarding data historian structures. Ignition is known from its internal historian that Ignition has. Of course, when we have Ignition 8.3, which is coming out later this year, we have a full new historian inside of Ignition. But the UNS is not really connected to an historian straight away. The UNS is just a data structure, and whatever we do with the data structure is up to us. If we want to historize the entire data and data structure, we can do that. It's just as simple as setting some checkboxes, and Ignition will historize the entire data structure. Of course, that will mean that we need a lot of data also, because if we use all the data and we want to historize all of it, it will consume some data. So you have to think about what's the goal eventually, but it is possible, of course. Can we connect to set up and test? Do we need multiple edge devices? Yep. Okay. A question here. I think we need to dive into that. I also see that it's 12 o'clock already. So I hope I answered most of the questions. The ones that I didn't answer, we will take up after the webinar. Thanks all for joining, and hope it was a valuable webinar. If there are any questions, please reach out to us. We're happy to help. And with AT automation, we will help you to master your growth. Thanks. Bye.